Hi everyone, Ms. Millender here. This is the fourth film in our 4-film series about dimensional analysis. So now we get into the thick of things, and this is where all the math is happening. Why do dimensional analysis in the first place? Well, it's what we use to show how certain units are converted to other units using conversion factors. Here's an example of why we need to use it. Here's the story. A detective was given 48 hours to gather the evidence needed to make a case against a suspect. How many days is that? You probably said 2 without even thinking. 2 it is. But in fact, you did do a calculation in your head in order to get this number. And what was that? 48 divided by 24 gives you 2. But the problem is there's no units, and you gotta have units on everything. So let's take a look at units for a second. So we have 48 hours divided by 24 hours. The hours will cancel and we get an answer of 2. But in fact, it's 2 days is what we're looking for. The hours canceled and days appeared, but it was almost like magic. The days wasn't anywhere, and now it is. The purpose of dimensional analysis is to actually show the original units being canceled and being replaced by the other units. And there's no magic, which is kind of sad, but there it is. Let's go through a step-by-step instruction on how to show your work for dimensional analysis. Okay, the first thing you're going to do is make a flowchart that looks kind of like this. You have hours, and you draw an arrow and you tell what units you want in the end. So you want days. Then you take the number that you were given at the beginning, which was 48 hours, and you put that over a 1 because you want to make that into a fraction. Now what you have to do is look back at your flowchart and say, okay, I want hours to days, so I'm going to go over to my handy dandy sheet and see what I can find. So this is what I find. I can find hours compared to minutes, and I can find days compared to minutes, but I can't find hours compared to days. Now, I know that you know how many hours in a day, but for the sake of this example, just play along, okay? All right, so there's no direct connection between hours and days. So what we're going to have to do is connect hours to minutes and then minutes to days. So I had to adjust my flowchart. So here we have our flowchart. So what does that, how does that help? So if you look at your flowchart and you look at the arrows, the number of arrows you have is going to tell you how many conversion factors you need. And the way we teach it is with parentheses, so that's how many sets of parentheses you're going to need in your dimensional analysis in order to get to where you want to go. So count the arrows and add that many sets of parentheses and lines to your equation. So we have 2 arrows, so we have 2 sets of parentheses, and we start with the number we were originally given, and it's over 1 to make it into a fraction. So here's what we've got. However, just as an algebra reminder, in order for things to cancel, they have to be on opposite sides of the fraction, which means one would have to be a numerator and the other would have to be a denominator, or vice versa. And they have to be separated by a multiplication or division function. So you have to keep that in mind, and that's a source of blunder all the time, is that people don't make sure that it's multiplication and division. Let's move on. What you're going to do is you're going to add the units and the values into those fractions in the sets of parentheses so that the units you start with will cancel and the units that you want will remain uncanceled in the end. So we're going to start by putting in 1 hour, and that's diagonal, you can see from the hours in 48. Now then we're going to add 60 minutes on top because according to our flowchart, we want to convert hours to minutes. So the hours cancel, and so far I'm left with minutes, which is really nice. But you can see in the next for the next conversion factor, I want to cancel minutes and I want to end up with days. So in order for the minutes to cancel, they have to go on the bottom, and 1440 minutes in a day. And look what cancels. The minutes cancel, so I'm left with days as the unit, which is what we want. So here we've got it. Just another algebra reminder. When calculating and multiplying fractions, you multiply the numerators together and you multiply the denominators together. So we've got that happening and that happening, so we end up with these two numbers. Don't forget the unit, days. And in math, there are times, actually there are often times, when you leave your answer as a fraction. But you never do that in science because answers left as a fraction don't really tell us that much. Because you'd never say, oh, I have 2880 over 1440 days to do that. It doesn't make sense to leave them as fractions. So you have to do the final division to get the correct answer and carry the units over that don't cancel. Days is the only unit that's not canceled. When we divide these, we get 2. Now, what about sig figs? We talked about sig figs in the earlier video. Time units are by definition, so no sig figs. So that's the minutes over hours and the days over minutes. And the 48 hours is a counted number, so there's no uncertainty, so no sig fig. So this is the very rare case when the answer doesn't have sig figs either. It's kind of weird, kind of cool. All right, so here's a practice problem for you. Go through the process just like we did in the video, showing all of your work while you're converting 47.0 miles to kilometers. So you can pause and get that done, and then we'll move on to the next part. Okay, so here's a new situation. What if the unit is a fraction? And fractional units come up all the time. You've already done one with density, for example, grams per milliliter. So that's what a fractional unit is. And here, I'm going to ask you to convert miles per hour to meters per second. So first of all, miles per hour, the way it's written right there with mph, not everyone's going to read that as a fractional unit. So here's what I would do. I would just convert or rewrite mph as miles per hour, mi/hour, or mi over hour. It just is easier. And just for those who don't know, m per s is meters per second. Okay, so let's do our flowcharts. We want miles per hour to go to meters per second. When you're converting these, you cannot convert miles to seconds or hours to meters. It's just not even in the same, they're not even measuring the same property. So if you notice that the miles are in the numerator and the meters are in the numerator, and they're both measurements of length. So what you're doing is you're converting miles to meters. If you look at the denominators, they're both time, per hour, per second. So we're converting hours to seconds. So you're going to be doing both conversions simultaneously or in the same equation. So let's try this out. I look at my handy dandy sheet and I'm going to go from miles to kilometers to meters. That seems the easiest way to do this for me. And again, you may know how many seconds are in an hour, but just for the sake of the example, let's go from hours to minutes to seconds. So that's how we're going to get to meters per second. But the process is the same as what we just did. So you look at your arrows, and you've got 4 of them. So you're going to use, the jingling is my dog scratching her neck. So you're going to use 4 conversion factors to get from where you start to where you want to be. All right, we have our 65.0 over 1, but when you're using fractional units, you have to separate the units into the numerator and the denominator, just like you did with the numbers. So miles per hour is miles over hours. All right, and we want 4 conversion factors. That's what we need to use. And then you just pick where to start. I'm going to start with the numerator, but it doesn't really matter. So the first thing that I want to do is be able to cancel the miles. So I'm going to put the miles on the bottom, and I want to convert the miles to kilometers, so I put that on the top. And those numbers I got just from looking at the handy dandy sheet. So now the miles cancel. But I'm not done with the numerator yet, because I don't want kilometers, I actually want meters. So I put kilometers in the denominator, so that way they're diagonal from each other and they'll cancel. And I want to convert the kilometers to meters, so I put those up there. Now I could have gotten those numbers, I don't know if they're on the handy dandy sheet, but you could have gotten those right off of the number line. But anyway, so the kilometers cancel here. So now I'm left with the meters in the numerator, and that's what I want in the end. So I'm kind of done with the numerator, but it is not a separate equation. What I want to do now is I want to convert the hours to seconds. So go way back to the beginning to our original number, and you'll see that 1 hour is in the denominator. So what I want to do is cancel that hour, so I have to put it in the numerator here. What do I want to change hours into? Minutes, so I'm going to put that on the bottom. All right, what cancels here? The hours way back at the beginning and in this conversion factor. I don't want minutes, I want the minutes to cancel, so this time I'm going to put them in the numerator. And I want ultimately to have seconds as my unit, so the minutes cancel. And as you remember, all the numerators get multiplied together, all the denominators get multiplied together. And personally, I would do this in one fell swoop on your calculator. I would say 65 times 1.609 times 1,000 times 1 equals divided by 1 times 1 times 1 times 60 times 60 equals. That way, oops, I only have to do it that one time, and I get 29.05138 meters per second. Great, so now let's go back and look and try to figure out the sig figs. Working backwards, minutes and seconds, by definition, same system. So no sig figs. Same with hours and minutes. Time, by definition, no sig figs. The 1,000 meters to 1 kilometer, also no sig figs, in the same system. They're both powers of 10. You don't have to worry about it. Here in the first conversion factor, we're comparing kilometers to miles. We don't look at the miles because that's a power of 10, but we do look at the 1.609, and that has 4 sig figs. And we always, almost always, look at the number that we start with as a sig fig. Okay, so the 1 doesn't count, it's a power of 10, but the 65.0 does count, and that has 3 sig figs. So 65.0 has 3, 1.609 has 4, so how many in our answer? 3 is correct. So there is your answer. So now let's do a practice problem with fractional units. So again, keep your notebook open in front of you, follow the same steps, show all your work, and this time you're converting 1240.0 gallons per hour to liters per minute. That would be like a pretty slow waterfall or a dam or something, how much water goes over in a certain amount of time. Now you know everything there is to know about dimensional analysis, so all you need to do now is practice, practice, and be sure to use your notes when you're doing these problems. Thanks for listening.